Good evening. This is Team 6. This is Jose Lopez, Richard Jadusingh, and I'm Aldo Melgarejo. And today we're talking about the design of a power transmission system. Our power transmission our system was to transmit 8.5 horsepower. The initial RPM was to be 660. Our output was to be 30 RPM. And our shafts were to rotate in opposite direction. They were also to be perpendicular and aligned on the same plane. So when you're facing each shaft, they should rotate opposite each other. The targeted applications for our transmission system would be farm equipment such as tillers or portable concrete mixers. These situations call for a high torque and low RPMs. In our literature survey overview, we found that most of these applications use horsepower ratings anywhere from 8 to 20, and their average cost is around $2,700.
For our first design that we tackled, we chose to do a design where we would have the input shaft as such attached to two spur gears. In this scenario, it was, I believe, a 12 tooth with 72 and then 14 with 66, I think. And then this was to be a 1-to-1 ratio with this one, and they were going to be perpendicular and in line. The reason why we could not go with this alternative is because Boston Gear catalog does not have a 14 tooth gear, nor do they have gears in this setup, which these would be a miter gear, and they simply do not make these. This was a second design alternative, which is more similar to what we ended up using, but the problem here was that the bearing that would have to be placed here would interfere with this shaft, so we instead decided to invert this facing the other way and have the output gear in front of it, and we wouldn't have any interference with the bearing or this shaft at all. Here's our final proposed design. As you can see, we ended up having 4 sets of spur gears, which is attached to a bevel gear. All these parts are straight from the Boston catalog and could be ordered at any given time.
The shaft design involves performing a force analysis on each shaft in the transmission. With an assumed length of each shaft, taking into account the bearings and widths of each gear, a force analysis is performed calculating the resultant forces at each bearing by taking the moment about the y and the sum forces about the z-axis. With this data, you make a moment and shear diagram, and you calculate your total moment for the maximum bending point on the shaft, and you take this and calculate your diameter for the shaft. Shown here are the diameters and lengths of each shaft on the transmission. Once you have your diameter, you can perform the Goodman analysis to determine the factor of safety for each shaft. By calculating your von Mises stresses, you are able to calculate your factor of safety, and these are the resulting factors of safeties for each shaft, all of them above 1.
All right. For gear selections, once we determined a final setup for our transmission system, we went into the Boston Gear catalog using their criteria and found our gears that gave us a final drive of 1 to 22 gear ratio. We then used the AGMA strength and bending equations to verify that our gears would not fail under the load. For the bearing selections, once the shaft analysis was completed, we used the reaction forces on each bearing location and calculated a C10 rating. We then looked in the Timken catalog and found a C10 rating greater than the C10 calculated. We also had to take into consideration the minimum shaft diameters to select a proper bore size of the bearing.
For a transmission case, we decided to have a step setup where we would have a front cover, middle cover, a rear plate, and the rear casing for the bevel gears. With this setup, we begin the assembly with the middle plate, which is as thick as this extrusion shows right here, where the main and strongest bearing of the transmission is pressed in, followed by the intermediate shafts and all the other shafts afterwards.
The bearing and gear costs were taken from wholesale bearings and drive supply, where you can purchase quality industrial products online at discounted prices. Shown here are the prices for each gear on the shaft, not including the shipping and handling cost or any machining work that needs to be done to the bore diameter of the gear. Shown here are the bearing costs. The bearing number was simply inputted into the website and it gave the prices for each bearing. The shaft costs were taken from onlinemetals.com, and shown here are the exact diameter and dimensions of each shaft and the corresponding cost. The total cost of the transmission comes out to $2,427.55. This includes $200 for the machine work on the bearings and shafts and gears. The labor, which would be $17 per day for 2 co-workers, at a total of 6 hours for assembly, and a cast iron case for $300.
For a practical application, we decided to create a tiller to attach to our transmission in order to be able to cultivate land, such as the applications that Aldo said before. This application is ideal because our transmission is able to put out huge amounts of torque at low RPMs, which is required for the tilling action. For the major maintenance of this transmission, we decided that every 100 hours of operation, the oil level should simply just be checked and refilled if necessary. Every 1,000 hours of operation, the oil should be changed out and replaced with new oil. However, for major maintenance, every 10,000 hours of operation, the transmission should be broken down and inspected for their bearing quality and gear quality. This is because when we did the analysis for the bearings, we assumed the 12,000 hour operation for the bearings.
In conclusion, a power transmission system was successfully designed. Gears and bearings were selected from the Boston Gear Catalog and the Timken Bearing Catalog. Using equations learned in the class lecture and in our textbook, we determined that the bearings and gears passed the factor of safeties and would not fail. What we learned throughout this project is that a lot of work and time goes into designing a transmission system. If starting all over from scratch, we would use a different calculating method that would store all of our data, so we may go back and change any values if necessary, such as an Excel file.